Alright, so the direction says use a graph to determine the model, then find the equation for best fit. So we're going to use our calculator to find the equation of best fit. Now I know some of you, after we put in the points, you're going to be good enough that you can immediately write the equation. For today's activity, we're going to go through the calculator method, alright? So let's take these points and let's start and graph them. We've got -2, -7, 0, -3, 1, -1, 3, 3, and 5, 7. Sorry, 5 up to 7. There we go. So we can see we have a straight line. So this one's definitely going to be linear. Now, let's build the equation. Let's use our calculator method. So we're going to go into stat, edit. We're going to type in our L1s and L2s. So x is -2, 0, 1, 3, and 5. Y, -7, -3, -1, +3, and +7. I've got them typed in. Now we're going to go back to stat. We're going to go over to calc, go down to number 4, linear regression, and then go down to calculate and push enter. So it says our A is 2 and our B is -3. Let's type it in. Let's write it. Y equals 2x minus 3. Alright, so that was our first example. Now let's look at the second one. Let's plot our points first and see what we would get. So -3, +2, -3, +1, 2. -2, -1, -2, -1. -1, -2, -1, -2. 0, -1, 0, -1, and then 1, 2, 1, 2. We can see we have a quadratic this time. So now let's just build the equation. So from those points, we're going to go back to stat, edit, and this time we've got to erase the old points. And type it in. So L1s is going to be -3, -2, -1, 0, and 1. L2s is going to be 2, -1, -2, -1, and 2. Now we'll go back to stat, calc, go down to number 5, quadratic regression, calculate, and we get y equals, A is 1, so 1x squared, B is 2 plus 2x, C is -1, so -1. And there is our equation. Now, something I want you to notice, on our linear one, our y values, even though they were consistently increasing, right? As the x values went up, the y values went up. So for linear, you're either going to have increasing y values, or if the slope is negative, you'll have decreasing y values. Over here, if we look at our y values on quadratics, we have a 2 at the top, a 2 at the bottom, a -1, a -1, and -2 in the middle. So you're going to see repeating terms around a vertex. And your vertex is going to be either the highest or lowest. So you should be able to look at your points and determine if it's going to be linear or quadratic just from the y values. If you're struggling a little bit with that, then just go through the steps, plot your points, stat, edit, and then build your equation. All right? So let's do a couple more. Number 3. First thing, I'm going to plot all those points. So +1, -5. Boom. +2, -2. +3, -1. +4, -2. +5, -5. So we have a quadratic again. And you do see that our y values were repeating. Now let's get the equation. So we're going to go to stat, edit, erase your L1s and L2s, and let's type in our values. So I've got 1, 2, 3, 4, 5. For L2s, -5, -2, -1, -2, -5. Go back to stat, go over to calc, go down to the quadratic regression, number 5, and go down to calculate. We get A is -1, B is 6, C is -10. So our equation is y equals -1x squared plus 6x minus 10. Let's do one more on this video. Let's go to number 4. First, we're going to graph it. So, -4, 7, -4, go up to 7, put a dot, -2, 6, 0, 5, 2, 4, and 4, 3. So, this time we've got a straight line. So this one is definitely linear. There we go, having some spelling issues today. Now all we need is our equation. So, stat, edit, we're going to type in our L1s and L2s here. So we've got -4, -2, 0, 2, and 4 for L2s, 7, 6, 5, 4, and 3. Go back to stat, calc. This is linear, it makes a straight line, so number 4, and go down to calculate, push enter. So this one is y equals, it says -0.5, x, and then plus 5. So we have our equation, we used the strategy. I'm going to stop our video here and we'll continue with it back on the next video.